Hello students. So in this video, we are going to start with pair of linear equations in two variables. First, let's see what are variables, constants, all those stuff. Then let's get into the equations, pair of linear equations. Okay. So as you can see, what are variables? Variables are symbols, okay, whose values are not fixed. So we know the variables, right? For example, the English alphabets. It need not be the English alphabets. It can be any symbol, okay? For example, something like this. This is known as alpha, beta, okay, where this is bit extended. Okay, you write B and the other side is extended a bit like this. And gamma, or let's say phi, this is called phi, and mu, okay, eta. There are so many things, okay? All these are variables, okay, because their values are not fixed. A symbol, if its value is not fixed, then we call it as variable. Okay, so what is a constant? It is the opposite of variable. Okay, a symbol whose value is fixed. For example, all the numbers 1 2 3 4 5 so on, and pi value. What is pi? 22/7, isn't it? So pi is also fixed. So symbols whose values are fixed are known as constant. Symbols whose values which are not fixed are known as variables. Okay, then as you can see, algebraic or mathematical expression. What is an algebraic expression or a mathematical expression? It is simply the combination of variables and constants. Okay, if you combine variables and constants by any of the sign, plus sign or minus sign or into or division, any of the sign, then we call it as a algebraic expression. Okay, it may not be variables and constant. It can be with variable itself. Okay, and variables and constant, any combination. Okay, for example, what is a tea? Tea is a combination of milk, tea powder, sugar, and sometimes ginger, everything, isn't it? That is tea. Similarly, algebraic expression is a combination of what and what. It might be variable and variable, or variable and constant, anything. For example, let's say 6 is a variable, x squared is a 6 is a constant, x squared is a variable. You combine it using plus sign or into sign or division or minus, anything is fine. All these are called as algebraic expression. Okay, now if the variables and the constants are in product, we consider that to be one term. For example, like this, 5 into x into y into z. See, all these things are in product, isn't it? 5 into x into y into z, all the things are in product. So we call this as one term. Okay, one factor or one term. Okay, now let's take another example, x square plus 3. So here x square is one term, 3 is another term. Okay, why the all together we cannot call it as one term? Because there is a plus sign. So whenever plus and minus comes, we get different parts. Okay, so this is one part and this is another part. So this is called as a term and this is called as a term. Let's take another examples. As you can see, 5 plus x over here, there are two terms. X square minus y square, there are two terms. But x cubed by 5, how many terms are there? No, two terms are not there. It is one term, because x cubed by 5 is actually 1 by 5 into x cube. I can write it like this, isn't it? So they are in product. If they are in product, we consider it to be one term. Okay. Similarly, the next one, 5 into y square, that is also one term. Okay. If things are in product, we consider it to be one term. Let's take another example. 3abc plus a plus b plus c. Now, how many things are there? How many terms are there? If you observe this 3abc, all the things are in product. So this is a term, this is another term, this is another term, and this is another term. So totally there are 4 terms. Okay, whenever plus and minus comes, we get different terms. Okay, yeah, let's get into the equation. So what is an equation? See, what we are dealing is linear equation, isn't it? So let's understand what is an equation. An equation is an expression which is equated to something. Okay, it need not be 0. It can be equated to anything. For example, let's take an expression. Okay, let's say we have got x square minus y square. It's an expression. If I equate it to something, let's say 5, it is actually equating it to 0. That will be the proper definition. But see, anyhow, if I get this 5 to the other side, automatically it will become 0, right? So it need not be equated to 0. It can be equated to anything. Okay. So x square minus y square is equal to 5. This is an equation. Okay. So all the examples for the expressions 5 plus x square minus y square, x cube by 5, 5 into y square. If you equate to something, then it will become equation. I hope it is clear the difference between expression and equation. Remember, if I write it like this, ax square plus bx plus c. What is this? This is just an expression because it is not equated to anything. If I equate it to anything, let's say 0, then it becomes equation. Okay. Now, the thing that we are dealing is linear equation, isn't it? We are discussing linear equation in two variable. Now, an equation is said to be linear. Remember this, an equation is said to be linear if the powers of the variable or the highest powers of the variable is 1. Okay. Let's take an example. 6x plus 2 is equal to 0. Okay, this becomes, yeah, that's an equation. Here, which is the variable? X is the variable. What is the power of x? 1. Is there any other highest power of x? No. Therefore, the highest power is 1, which means the degree is 1. So, if the degree is 1, then we call it as linear equation. Now, how many variables it has got? It has got only one variable. So, this is linear equation in one variable. Okay, linear equation in one variable. Let's take another example. 3x plus 2y is equal to some 5. Just focus on the variables. What are the variables here? X and y. What is the power of x? It is 1. What is the power of y? It is 1. So both the variables powers are 1. That is, the degree of the equation is 1. Therefore, this we call it as linear equation in two variables. Okay. We can also increase the number of variables. You can also have 3 variables, something like this: 3x plus 2y plus 5z equal to 10. This is a linear equation because x power is 1, y power is 1, z power is also 1. All the variables power should be 1. Okay. Therefore, this is linear equation in 3 variables. Suppose if you have got like this, 5x plus 2y squared is equal to 10. Is this a linear equation? No, because here x power is 1, but y power is what? 2. The highest power of the other variable is 2. Therefore, this is not linear. Both the variables power, highest power should be 1. Okay. Only then we can call it as linear equation. Okay. What will be the standard form for linear equation in two variable? As I have written, linear equation in two variable. An equation of the form ax plus by plus c is equal to 0. Okay. Where a, b, c are known as arbitrary constant. See, A, B, C are actually constant. The meaning of arbitrary means A, B, C value is not fixed right now, but it will be fixed later. Okay, for example, you can have something like this: 2x plus 3y plus 5 is equal to 0. So your A is 2, B is 2, B is 3. Okay, so that's the meaning of arbitrary constant, meaning it is a constant whose value is not fixed right now. Okay, in general, we are writing it in general. Okay, we are writing it in general. That is why we are using ax plus by plus c is equal to 0. Please do not get confused. A, B, C are not variables. They are constants. Okay. We have got many numbers, right? Constants are basically numbers, isn't it? We have got many numbers. So while writing in general form, we write it like this. And remember, A and B should not be equal to 0. Why? Because if you, let's take this equation, ax plus by plus c is equal to 0. If you make A as 0, 0 into x is 0. So this complete thing vanishes. Now what you are left with? By plus c. So it is linear equation in one variable, isn't it? But what we are dealing is linear equation in two variables. So that is why a value should not be equal to 0. Same logic applies for b. If you make b as 0, 0 into y becomes 0. This entire thing becomes 0. So this thing vanishes. So you're left only with constant. Okay. That is, there are no variables. Okay. So you cannot have a and b as 0, but you can have any other value other than 0. You can give fractions, you can give irrational numbers, you can give rational numbers, anything that you wish you can give for a and b except 0. For c, there is no exception. You can give all the values. C can also be 0. You can give the value of c as 0. There are no restrictions. But for a and b, there is a restriction. That is, you cannot give the value of a as 0 and the value of b as 0. Okay. So I hope it is clear. Linear equation in two variable. Okay. What is a linear equation in two variable? It's very simple. You take an equation. If the variables involved, if the variable involved has power 1, highest power, okay, if it has got the highest power as 1, all the variables, if they have got the highest power as 1, then you call it as linear equation. Okay, otherwise it is not a linear equation. Let's take one more example. 6x squared plus 5y is equal to 3. Here, is it a linear equation? No, because x power is 2, x highest power is 2, y highest power is 1. Both the powers should be 1, only then it will become linear. So this is not a linear. Okay. 6x plus 3 is equal to 10. Is this a linear equation in two variables? No, because there is only one variable. It is linear equation in one variable. Okay. If it was 3y, then you could have told it is linear equation in two variables. Okay. So I hope you have understood what is linear equation in two variables. Let's get into the next very important concept known as solutions of linear equation. Okay. Solutions of linear equation. Let's understand solution of linear equation in two variables. Okay. Solution of a linear equation is simply those values which, when put in the place of or substituted in the place of x and y, will satisfy the equation. That is, LHS and RHS will become equal. Let's take a simple example. X plus y is equal to 5. Now, what is the value of x and y so that the LHS and RHS will become equal? I can give x as 3 and y as 2, isn't it? X is equal to 3, y is equal to 2. 3 plus 2 is 5. So LHS and RHS is equal. Is there any other value? Think. Very good. You can give x as 4, y as 1. Any other? Very good. You can give x as 5, y as 0. You can also reverse. You can give x as 0, y as 5. Again, 0 plus 5 is 5. Or you can give x as 1, y as 4. Think any other values. Yeah, you can give x as 4.5, y as 0.5. You can give any values, isn't it? But the thing is, the LHS and RHS should become equal. So if x is 4.5 and y is 0.5, 4.5 plus 0.5 is 5. So LHS and RHS is equal. Or you can give x as 4.2, y as 0.8. You can also give x as 10, y as minus 5. You can give x as 100, y as minus 95. You can also give x as, let's say 3 by 2 and y as 7 by 2. Add it, what do you get? 10 by 2. 10 by 2 is 5. You can also give it like this. Or you can give x as 4.3, y as 0.7. Now, do you think this is going to stop? No, isn't it? You can find such values, right? You can keep finding such values, which means for a linear equation in two variable, that is, if you take only one equation, okay, I have taken only one equation, that is x plus y is equal to 5. For a linear equation in two variable, you can find infinite solution, meaning you can find infinite values for x and y such that they'll satisfy. Okay, you can find like this infinite, many values, how much ever you wish, more than you wish. Okay, you can find as much a solution as you wish. Okay, so if you take only one linear equation, just one, okay, for that one equation you can find infinite solutions. Okay, so all this is regarding linear equation in two variable. But what is our chapter name? What is the chapter that we are dealing with? Pair of linear equation, isn't it? The chapter that we are dealing is pair of linear equation, meaning we are going to take two equations at a time. For example, something like this. See, I have taken one equation, x plus y is equal to 5. Along with this, let me take one more like this, x minus y equal to 3. So as you can see, I have taken two equations at a time. So this is called as pair of linear equations in two variables. We also call it as system of equations. The same thing, we call it as system of equations, or we also call it as simultaneous equation. We also call this as simultaneous equation. Anything is fine. Okay. What is pair of linear equation? The name itself indicates you got linear equation. You're taking a pair. Okay. You're taking two equations at a time. That is known as pair of linear equations. Okay. Now let's see what is the general form. Okay. Let's see what is the general form. Now let me write it here. Now if it was only one equation, then we had already written the general form. Ax plus by plus c equal to 0. Isn't it? Only one equation, then you will write it. But there are two equations, right? So what I'll do is I'll make this first one as a1 x b1 y plus c1 is equal to 0. The next one a2 x plus b2 y plus c2 is equal to 0. I'm taking two equations at a time. So this is how generally we represent a1x plus b1y plus c1 is equal to 0. a2x plus b2y plus c2 is equal to 0. This is the general form. What are a1, b1, c1? Constants. a2, b2, c2? Constants. What are the things that cannot be 0? Very clearly, a1 cannot be 0. b1 cannot be 0. Because if they become 0, the variables will vanish, isn't it? Similarly, a2 cannot be 0. b2 cannot be 0, isn't it? So we got to know the variables that cannot be 0. Sorry, the constants that cannot be 0. So remember this general form, which is very, very important. What is the general form for pair of linear equation? a1x plus b1y plus c1 is equal to 0. a2x plus b2y plus c2 is equal to 0. Okay. Now let's understand the solutions for a pair of linear equation. What we saw was for a single equation. Now let's take two equations at a time and let's see what type of solution we get. Okay. So I've taken three examples, okay, to understand what type of solutions we might get for a pair, okay, for a pair of linear equations. So observe the first example. In the first example, we have got two equations, x plus y is equal to 5 and x minus y is equal to 3. Now we have to find solution. Remember, for a pair, solution means x value and y value, which should satisfy both the equations, the first equation as well as the second one. For example, if you take x as 3 and y as 2, this will satisfy only the first one, isn't it? Will it satisfy the second one? No, you just put it x is 3 minus y is 2. 3 minus 2 is 1. But what should we get? We should get 3. So this cannot be a solution. Solution means it should satisfy both. Both the equations should be satisfied. If you observe carefully, if I give x as 4 and y as 1, it is possible, isn't it? Give x as 4 and y as 1 in the first one, 4 plus 1 is 5, satisfied. In the second one, 4 minus 1 is 3, 3 equals 3, it is satisfied. Is there any other value? Think. You can pause the video and you can think, is there any other value of x and y that will satisfy both? No, not possible. Okay, there is only one value. Okay, let's get into the second example. In the second example, try to find the value of x and y which will satisfy both. That is, you should find x and y in such a way that if you add them, you should get 5. X plus y should give you 5. Similarly, x plus y should give you 3. Think. You can pause the video and you can check the values which will satisfy both the equation. Okay, 4 plus 1 is 5, but 4 plus 1 is not 3, right? 4 minus 1 is 3, but the equation that I have taken is x plus y equal to 3. So you can try as much as you wish, you will never get the solution because you're adding same things and you're getting 5 and you have to add the same things and get 3. It is not possible, right? It is not at all possible. Therefore, you cannot get any solution. X and y, there is no values. Okay. Now, if you come to the third one, okay, try the values. Very good. If you give x as 4 and y as 1, it is satisfied for both. Because I just checked the same thing, okay? I just put the same thing here and I'm checking it. 4 plus 1 is 5. 2 into 4 is 8, 2 into 1 is 2. So 8 plus 2 is 10. So I'm talking about the second one. You should get 10, right? You give x as 4, y as 1, 2 4s are 8, 2 1s are 2, 8 plus 10 is 10, 10 equal to 10. It is satisfied. Okay. What about the other values? Are there any values other than this? Yes, of course. X equal to 3 and y equal to 2 definitely will satisfy it. X equal to 0, y equal to 5 will satisfy it. X equal to 5, y equal to 0 will satisfy it. X equal to 4.5, y is equal to 0.5 will satisfy it. You can keep doing this. X is equal to 1 by 2, y is equal to, let's say 9 by 2 will satisfy it. You can keep doing this, okay? You can give x as 4.1 and y as 0.9, or you can give x as 10, y as minus 5. All the values will satisfy. There are more than one, which means there are infinite values. You can find as much as you wish. In fact, more than what you wish. Okay. So therefore, if you observe these three examples, we can clearly analyze that there are certain pair, we get only one solution for it. And there are certain pair, we don't get the solution at all. And there are another set of pairs where we get infinite solution. Therefore, we can conclude if I take a pair of linear equation, then there are three possibilities. Either it will have one solution, that is unique, only one, okay? Unique means only one. Only one. Or you might not get at all, so no solution. Or the third one, you might get infinite, as many as you like. Infinite solution. Remember, I'm not telling every pair will have all these three. I'm saying that every pair will have any one out of this three. Okay, any one, not all the three. Either it will have unique, or it won't have any solution, or it might have infinite solution. Okay. So we understood that for a pair, we have three possibilities. Okay. Now let's understand the graphical meaning of solution. What we did now is algebraical meaning. That is, if you substitute the value of x and y, the LHS and RHS will become equal. This is the algebraical meaning. So what is the graphical meaning? Let's understand that. Okay. So graphical meaning of solutions. Okay. Now let's take a single linear equation in two variable. Let's take only one. Okay. Now we have already learned that we can plot a graph for this, isn't it? So what type of graph we get? We get a straight line. Remember, whenever it is a linear equation, we get a straight line. Okay. Now, what are the solutions? We know that x is equal to 3 is a solution. X is equal to 3, y is equal to 2 is a solution, isn't it? And we also know that x equal to 4, y is equal to 1 is a solution. X equal to 0, y is equal to 5 is a solution. We get infinite solution, isn't it? Now, when we plot a graph for this equation, x plus y is equal to 5. Okay. Suppose we get something like this. Okay, x plus y is equal to 5. Okay, this is the graph that we get. Now, this x equal to 3 and y is equal to 2. That is the point 3, 2 or 4, 1 or 0, 5. All these points will be on the line. You can find these points on the line, on the graph itself. You can find on this. Okay. Now, let's say x is equal to 10, y is equal to 1. Is it a solution? No, it's not a solution, because 10 plus 1 is 11. It is not equal to 5. Therefore, it is not a solution. Therefore, this point 10, 1, that is x, y, will be not on the line. You cannot find this point on this line anywhere. You cannot find it. It will be somewhere outside the line, somewhere here, maybe. Okay. Or let's say 3, 5. Is it a solution? X value is 3, y value is 5. Is it a solution? No. Therefore, this point will not be on the line. It will be somewhere else. For example, somewhere here. Okay, this point might be 3, 5, and this might be 10, 1. Okay. If it is a solution, then you can find those points on the line itself. Okay. If it is not, if it is not a solution, then you cannot find it on the line. So this is the graphical meaning. Okay, but for a pair, if you take a pair, for example, in the previous question, x plus y is equal to 5 and x minus y is equal to 3. Here we got unique solution. X is equal to 4 and y is equal to 1, isn't it? This is a solution. Meaning this point 4, 1 will be on both the graphs. It will be on both the graphs. So there is a point which is on both the graphs or which is on both the lines. So what kind of point it will be? It should be an intersecting point or intersecting lines, isn't it? If you observe this point, which I'm enlarging, this point is also on this line. It is also on this line, isn't it? So if you are getting a unique solution, then if you plot a graph for this, you will get such a graph, that is intersecting graph. Okay. Now we had another example, x plus y is equal to 5, x plus y is equal to 3. Now, did we have any solution? No. There are no points or common points, I can say. Okay. Because if there are two equations, a point should be on both, isn't it? So there is no point which is on the both. Meaning, I can also say it like this. See, if it has got one solution in the previous one, if it has got one solution, then both the lines will meet once. If it has got no solution, it means both the lines will never meet. What do we call lines which never meet? We call it as parallel lines. Therefore, for no solution, we get parallel lines. And for the another one, we had infinite solution. Meaning, I'm sorry, let me take it back. Yeah. So if you take an infinite solution pair, okay, if it has got an infinite solution, it means both the graph or both the straight line meet many times or meet infinite times. See, if it has got only one solution, it meets only once. If it has no solution, it never meets. If it has infinite solution, it means it will meet infinite times. Then the line should be something like this. That is coincident, one top of the other. The first one and the second one should be one top of the other. It should be coinciding. As you can see, 1, 2, 3, 4, 5, 6. There are so many points that are common to both, isn't it? You can also extend a bit. There are so many points that are common to both the lines. Okay, that is why coincident. So if a pair is having unique solution, then the graph will be intersecting. If the pair is having no solution, then the graph will be parallel. If they have infinite solution, then the graph will be coincident. Okay. And one more important thing is, if a pair has a solution, whether it is unique solution or infinite solution, it should have solution. If it has a solution, then we call that pair of equations as consistent pair. Okay. If it has a solution, we call it as consistent pair. Otherwise, if it doesn't have solution, inconsistent. If it doesn't have solution, we call it as inconsistent. Okay. For example, this one, x plus y equal to 5, x plus y equal to 3. It has no solution. Therefore, it is inconsistent pair. But the first one, x plus y is equal to 5, x minus y equal to 3. It has got a solution, unique one. That is, therefore, it is consistent. If you take the other one, x plus y is equal to 5, 2x plus 2y is equal to 10. This has infinite solution. Anyhow, it has a solution, right? Therefore, this is also consistent pair. Okay. I hope you guys have understood this. In the next video, we'll see the conditions for solutions. Okay. What are the conditions? If you want to have unique solution, then what condition should the pair satisfy? Or if you want to have no solution, if you want to have a pair with no solution, then what is the condition that the pair have to satisfy? Let's see in the next video. I hope you enjoyed this. Thank you, students.